Hi everyone, today we're looking at adding and subtracting rational expressions. I notice a lot of students really struggle with this, so take good notes, take your time, pause the video when you need to. Just recognize that this is one of the harder topics to conquer in Algebra 2. So we have some vocabulary here, the least common multiple. The least common multiple, also called the lowest common multiple, or the smallest common multiple of two integers, a and b, is the smallest positive integer that is divisible by both a and b. A complex fraction is a fraction that has a fraction in its numerator or denominator or both. And some examples of complex fractions would be if you have 1 over x all over y, or let's say we have the number 3 all over 1 minus 1 over 2y, or x minus 2 over x, all divided by 3 over x minus 1. All right, so those are all examples of complex fractions. And so this lesson has a lot to do with finding a common denominator, which can be sometimes a difficult task enough. Never mind, we're using polynomials. So to find the least common multiple, we're going to do some steps here, so just try to follow along. We want to find the prime factors of each expression. All right, so to find the prime factors, we're going to factor both of these. And you'll notice that we have a GCF in this first one of 3. So we're going to take that 3 out. And then x squared minus 3x minus 10 is still factorable to x minus 5 and x plus 2. So that's the first one factored. All right, now let's factor the other one. We have a GCF of 6, so we're going to pull the 6 out. And this 6 can be broken down a little further to prime factors of 2 and 3. Right, now the next step says write each prime factor the greatest number of times it appears in either expression. Simplify where possible. All right, so we have a 2. We have to include that. We have a 3. Now 3 only occurs once in either one of these, so we only need one 3. Okay, next, and let's just cross off as we go to keep track here. We took care of 2, we took care of 3. All right, now we're saying, oh, here's an x minus 5 that occurs once. We're going to need to take care of that. Let's cross that off. Then we have an x plus 2 that only occurs once in either side, so let's put that here. And then lastly, we have x plus 5. And instead of writing 2 times 3, we can just change that to a 6 and then rewrite the linear factors. All right, so let's take a look at the next one. First, we want to factor each expression. We can pull a 2 out of the first one. I'll do that in red. Looks like we can pull a 15 out. All right, and then what we're left with is x squared minus 4. And that's the difference of 2 squares. So we do want to just continue to factor this 15 to be 3 and 5. We want prime factors here. All right, so we're going to look at each one and we're going to see what we need to pull out, all right, to come up with our least common multiple. So we know for sure we're going to need a 2. Cross that off. And we know we're going to need a 3 and a 5. All right, now notice we said we want to write each prime factor the greatest number of times it appears in either expression. So we have x minus 2 here, it only appears once. We have x minus 2 here, it appears twice. So we need to write it twice. We're writing it the greatest number of times it appears in either expression. And since it appears twice here, we need to write it twice. All right, that takes care of all of those. And then all we have left is x plus 2. And then 2 times 3 times 5, that's 30. So let's rewrite this. And that would be our answer for part B. At this point, I would say pause the video and try to do C and D on your own and come back when you're ready. So we're going to pull a 4 out. X squared minus 9 is the difference of two squares, and 4 can be rewritten as 2 times 2. Okay, that's fully factored. Now let's work with the other expression here. First, we're going to pull a 6 out. Six can be written as 2 times 3. And then x squared plus 6x plus 9 can be written as x plus 3 times x plus 3. All right, so I'm going to repeat this again. We're going to write each prime factor the greatest number of times it appears in either expression. So we know we need a 2. 2 occurs twice here, so we know we need 2 2's. We know we need a 3. It appears once. All right, now, next one, x minus 3. Appears once. It doesn't appear here at all. We know we need 1 x minus 3. And then the last one, we have x plus 3 occurring once here, x plus 3 occurring twice here. We need to put it down the greatest number of times it appears in either expression. It appears twice here, so we know we need 2 of those. All right, 2 times 2 times 3 is 12. Last one. All right, now we're going to write our least common multiple. So we have 5. We have a 2. We have x plus 2. Occurs once here, it occurs once here, so I only need to write it once. Then we have x plus 1, it only occurs once, so we need to write it once. And then we have x minus 2, it only occurs once, so we only need to write it once. All right, so this page really sets us up for the entire lesson. If you were confused on this, I would say go back to the start of the page, rewind this recording, and listen to me again explain how we're approaching finding this least common multiple. When you're ready, go on to the next page. All right, so the rest of this lesson should be fairly easy as long as you were able to understand what we did on the preceding page. I also do have a video on my channel. It's another short little video that demonstrates how to do this. You may want to watch that first, or just note that it's another reference for you. All right, so we're going to go ahead and use those skills to come up with our common denominator for part A using our least common multiple technique. And I'm going to need one of the x plus 4s, one x plus 1. X plus 1 only happens once on for either one of these, so I will only need 1, and then I'll need a 3. So let me write those in. All right, so now for this part, what we're going to do is we're going to decide if we need to add anything to the numerators based on this common denominator. So you want to write out what's already in the numerator and then leave a placeholder. So now we're going to do some comparison. So now what we're going to do is some comparison. We're going to compare our original denominator to our new denominator and see what is different, right? What is extra in the new denominator? Well, they're exactly the same except for the 3. So I'm going to add a 3 as the part that I need to add that is extra in my common denominator. Okay, now I'm going to look at the other one. I have 3 and x plus 1, and here I have 3x plus 1, x plus 4. So what's extra is this x plus 4. Because what we're doing is we're saying we're dividing this into our new common denominator and see what is remaining. Right? I have heard students describe it as saying, well, what is extra? So what's extra is this x plus 4. And now we've done the hard part. We're just going to, distribute and combine like terms. So 1 times 3 is 3. 5x times x is 5x squared. And then 4 times 5x is 20x. And you don't have to multiply out the denominator. We can just leave it in factored form. If you want, you may want to put the numerator in standard form. It just makes me feel better to do that. So I'm going to go ahead and do that. And here's our final answer for letter A. So I would suggest, trying letters B, C, and D on your own and come back to the video when you're ready. Okay, now we're going to come up with our common denominator. So we know we need an x minus 6. We're going to need 1x plus 2 because it only happens once with either term. And we're going to need a 4. All right, the next step is we're going to write what is originally in our numerators and leave placeholders. And then we're going to compare. So here's our original denominator. Right, now we have our new denominator. What's extra? What's remaining? The 4 is extra. So we're going to put that here. And now we're going to compare the other one. So what is extra in the new denominator? Well, x minus 6. We've done the hard part. We're going to combine like terms, and we're going to rewrite our common denominator. So we're going to distribute the 3x to the x, 3x squared. Okay, that takes care of this guy. And we're going to do 3x times minus 6. That's going to give me minus 18x. That takes care of this part of it. So that's all taken care of. And then lastly, we don't want to forget to tack the 4 on at the end. And then just rewrite the denominator. All right, and that's the answer to letter B. Let's take a look at letter C. We're going to factor first. All right, we've factored, just write out. If it says y squared, just write y 2 times. Now we'll come up with our common denominator. All right, so we have x occurring once in both terms, so I know I need an x. Let's write that in. Maybe we'll just cross these off as we go. And then for the next one, I know I need one y. I have one y here, but I have 2 here, and we need to write it as many times as it occurs in one of the expressions. So it occurs twice here, so I'm going to need 2 y's. So I'll write both those in. Cross those off. And then all we have left is the 4, so I'll write that in. Okay, we're going to rewrite our numerators and we're going to leave placeholders. Okay, now we're going to do our comparison. So we had x times y times y. We have that here. What's extra? A 4. A 4 is going to go in our numerator. This time we have 4x and y. We have 4x and y. We have y is extra, so a y is going to go in our numerator. All right, we've done the hard part. Now we need to distribute and then combine like terms. So now we're going to have 4 times 5y, that's 20y, plus 4 times 2, that's 8, plus y times 2x, that's 2xy, and then minus 4 times y, that's minus 4y. And then in the denominator, we have 4xy squared. All right, now we can combine like terms and write our final answer. Now, if you notice, we can take a 2 out of every term. So, I mean, I would accept the answer in this form, but if you wanted to reduce it a little further, what we could do is just say, well, we notice that every single one of these terms is divisible by 2. And then we could rewrite it again. So our final answer, if we continued to simplify, would be 8y plus 4 plus xy over 2xy squared. Last one, factor first. All right, once we're fully factored, we're going to find our common denominator. So we have x minus 3 occurs once in either term. X plus 3 we need to include because that occurs once, and 2, that occurs once. The original denominator to the new denominator, 2 is extra, so 2 goes with our numerator. And then again, comparing our original denominator with our new denominator, x plus 3 is extra, so x plus 3 is going to go here. Distribute and combine like terms. And once we do that again, we notice we could take a 2 out of each term. You know, you could take a 2 out of here. This is divisible by 2. This term is divisible by 2. So let's go ahead and do that, make it a little simpler, a little nicer to look at. All right, that's it for that page. Let's go on to subtracting rational expressions. Same exact idea. You're just going to have to remember the tricky part here, distributing that negative to the numerator once we've, come up with our common denominator and distributed. We have to make sure we don't forget to continue to distribute that negative. I'll show you what I mean. So let's go ahead and factor first as usual. All right, we're fully factored. Now we're going to find our common denominator. Our common denominator would require we have 1x minus 5 and 1x plus 5. Now we're going to compare. So we have the exact same original denominator with our new denominator. So I'm just going to put a 1 here. All right. Comparing the next one, the extra part in this one is x plus 5. So we'll put x plus 5 here. All right, now this is where you have to be really careful. So first of all, we're going to clean up that numerator. So 3x times 1 is 3x minus. Now I'm not going to even worry about that minus yet. I'm just going to multiply x minus 5 times x plus 5, which is going to give me x squared minus 25. And I still have x minus 5 and x plus 5 in my denominator. Okay, now I'm going to distribute that negative. So it would be negative times x squared would give me negative x squared, and negative times negative 25 would give me positive 25. All right, so we end up with 3x minus x squared plus 25 over x minus 5, x plus 5. And of course, I like to write the top in standard form, so I'm going to do that. So that's our final solution. All right, try letter B and letter C on your own. Come back when you're ready. Find our common denominator. In this case, we have x minus 5, 1, so we need that. X plus 5 happens only once in either one. We'll need one of those, and we'll need 1, 3. Now we're going to compare what's extra here, 3. So 3 goes with our numerator. Compare this to our original denominator. What's extra? X minus 5. All right, and just be really careful, following order of operations, simplify, try it on your own. When you're ready, restart the recording. Okay, at this point, I'm ready to distribute the negative. Don't rush through the steps. Really take your time and write out each step. And then at this point, we're ready to combine like terms. And that should be your final answer. Okay, again, factor first. All right, find your common denominator. All right, we're going to compare. They're the same, so we're going to put a 1 up there. Distribute and combine like terms. All right, at this point, I'm ready to distribute that negative. I'm going to distribute the negative to every term. So it's going to be negative x squared, negative 3x plus 28. Combine like terms. And that would be our final answer. Okay, last page. So this page, we're going to be simplifying complex fractions. It just means that if we're dividing a fraction by a fraction, we multiply by the reciprocal. So our numerator is 1 over x. We're going to multiply by the reciprocal of the denominator. Okay, we're going to end up with y over 2x. That was easy. All right, let's take a look at the next one. Well, before we can multiply by the reciprocal in the denominator, we have to clean up the denominator. We have to find a common denominator. So, all right, bear with me here now. Let's rewrite this. First of all, what does this mean? We have 1 over 1 plus x over y. All right. Our common denominator here, well, we need a 1 and we need a y. Just like, nothing has changed here, same process. We would need a 1 and we would need a y for our new common denominator. I'm just going to write our new common denominator. I'm just going to write a y. We have a 1 placeholder plus an x placeholder. Okay, we're going to do the same process. If we compare the 1 to this, what's extra? A y. If we compare the y to our new common denominator, there's nothing extra. We would just put a 1 there. Okay, so we end up with 1 all over y plus x over y. Now we can multiply by the reciprocal. So we're going to have 1 over 1, right? 1 is just 1 over 1, times the reciprocal of the denominator, which is going to be y over y plus x. And when you simplify that, you get y over y plus x. Now, I just want you to realize that this problem in particular becomes very difficult for students. There's something about just having so many fractions that it becomes a little confusing. So just take your time, all right? Maybe rewatch this problem, but just remember that we're just treating this denominator just the way we were doing all the problems on the past page. And the problems on the past page were much harder than what we were doing here, okay? So you may want to think about what I boxed out in red on its own before you go ahead and do that very last step where we get to do the fun part and we get to, multiply by the reciprocal of the denominator and then get our final answer. Okay? All right, there's one more to try. This is really tough one. All right, try it on your own. Come back when you're ready. Good luck. So we have a numerator and a denominator where we need to find common denominators. So I'm going to rewrite the numerator. It's 1 over x and 3 over 1, just to get me started. And then I'm going to write 5 over y plus 4 over 1. All right, so far so good. Now, I'm going to find common denominators for both the numerator and the denominator. So the common denominator here would be 1 and x, I'm just going to write x. And I have a 1 placeholder, 3 placeholder, okay? X compared to this, they're exactly the same. So we put a 1, and then 1 compared to this, well, x is extra, so x is going to go in the numerator. All right, let's look at the other one. Let's look at the denominator now. Our common denominator is going to be y and 1, or just y. 1 times y is just y. Put 5 and a placeholder, and 4 and a placeholder. Then I'm going to compare y compared to y. Well, that's just nothing, just 1. Y divided into y is just 1. And then if I compare 1 and y, well, y is extra, so y is going to go here. Now, it may help to just kind of make this line like really big so you really can see that you're dealing with, maybe even put it in a different color, that this is, dividing this up. That might help, okay? So what do we have in our new numerator? Well, we have 1 times 1, that's 1 plus 3x. All right, so let's write that. So we have 1 plus 3x over x, and that's going to be all over 5 plus 4y over y. Okay, so now we have a fraction over a fraction. That means we can multiply by the reciprocal. So this is the fun part. Let's do that. Well, it's all fun, really, but this is the really fun part. So we have 1 plus 3x over x multiplied by the reciprocal of the denominator. So that's going to give us y over 5 plus 4y. All right? And I think what I'm going to do, just to make it look a little bit nicer, is I'm going to distribute. So I'm just going to add parentheses here to remind me that I would have to distribute the y to the 1 and the 3x, and the x to the 5 and the 4y. So I still don't think it looks really simplified here, so we're just going to go ahead and do that distribution. So y times 1 is y times 3x is 3xy, x times 5 is 5x, and x times 4y is 4xy. Phew, that was a lot. It was kind of fun though. I hope you enjoyed it. Thanks for watching to the end and really giving it a try. I think that's great. Enjoy your day, and thanks for watching.